Hello everyone, and welcome back to the ccubed channel. Today, this is a tier 1 video for the GCSE Maths Foundation students and those who wish to start from the basics. So today we're going to be talking about the introduction to surds. We're going to be learning about what a surd is, how you can simplify surds, and what you can do with them basically, and what they are. This is an introduction, so we will be kind of looking more into this in the future with higher tier maths. So tier 2 videos will be looking more into what surds are and how you can manipulate them even further. But for this video, we're starting with kind of a basic knowledge of them. We're going to be doing the kind of standard procedures and rules. So this won't be very long. This will be quite a short one. So we're going to begin. What is a surd? So a surd is an irrational number. So basically, those that have like an infinite number of decimal places that don't seem to have a pattern. So we could say, for example, well, we got examples down here, but they can be represented as a surd of any root. So what I mean by this is, let's take these three examples here. So square root of 2 is an irrational number. It's a number where the decimal points don't really repeat themselves. It's kind of weird. It's just a very long an infinite number in terms of decimal point size. So this is a surd. That's what a square root is. It's a surd. Is a surd of power 2. Right? Now with powers of 2, we don't really write them in the surds, so we can just simply leave it as the square root of 2. So that, again, that's just a surd with power 2. So this is a surd of 5 with power 3, and that is basically just the cube root. In that situation is power 3. And now for the last example, we have a surd of 67 with a power of 10, so that's the 10th root of 67. So that's just, again, surd with a power of 10. That's all that is. So let us look at further, at least. We're going to be taking a look at simplifying them now. So there are different ways to simplify surds. This is pretty much the remainder of the video now. We're going to be doing basically a whole load of simplifying stuff now. So we have three examples here, and we basically just have to use our knowledge of square numbers to solve these. That's essentially what it is. So for example, square root of 4 is quite simply 2, because 2 times 2 is 4. That's simple as that. Square root of 16 is 4, and that's because 4 times 4 is 16. So that's quite simple as well. And then square root of 121 is 11. And that's because 11 times 11 is 121. So we've simplified these very basic surds. These are kind of like the elementary, easy ones. These are ones that actually have defined values. When they don't have a proper defined value that you can actually write, such as square root of 2, which is 1.414, and then they've got a whole list of digits, and that goes on forever, so you just have to leave it as root 2. That's the simplest you can keep it as. So in cases like this where they do have a strict defined number like that, then you can just get rid of the square root and you can just actually solve it. But in the case of square root 2, we know that the digits going further, so we can't really write that. It's not really feasible, so we just leave it as root 2 to be as exact as you can. So surds have multiplication and division rules, and we're going to be looking at that very quickly. So we have the square root of 2 times square root of 3. So if you were to multiply surds together, what you do is you quite literally multiply the numbers inside them. That is quite it. That's just basically it. So let's do root 2 times root 2, root 2 times root 3, so that we can put it in underneath 1 square root is 2 times 3. Maybe that times the actual times. So 2 times 3 we know is root 6. Well, 2 times root 6, so we get root 6 in the end. That's what we got. Root 2 times root 2, root 2 times root 3 is root 6. That's it. That's all there is to it. Next one, root 5 times root 2. So in this case we do 5 times 2. And that is root 10. Oh, I cannot do that properly. There we go, root 10. And that's all we get for that. Root 5 times root 2 is root 10. Now for the last one, this is a very interesting situation because we have root 3 times root 3. So we're multiplying root 3 by itself. In this situation, let's just do the same procedure as last time and we'll see what we get. So we're going to do root 3, so 3 times 3, and you're left with root 9. Now, we know that 3 times 3 is 9, so the square root of 9 is just 3. Oop, that's a bad 3, but you get the idea. So, we basically just simplified this out. So if you multiply root 3 by itself, you just get 3. And this is one of the proofs for that, actually, to show that that works. There's another proof you could do with Indices Laws. So we've covered the Indices Laws near the very beginning of this Algebra playlist. So if you want to go over that, I would recommend you do that just to make sure you know your Indices Laws. But very quickly, we're going to take a look at why this works using Indices Laws. So let's do 3 to the power of a half, because we know to the power of a half is basically a square root. That's what that means. So 3 times 3 to the power of a half multiplied by 3 to the power of a half. Oh, that's a bad. There we go. So we're multiplying the two halves together, basically. So remember when we multiply the same terms together, when we multiply indices, I should say, you just simply add them up. So half plus half is just 1. And so that is quite simply equal to 3. There you go, because 3 to the power 1 is just 3. And we proved that using Indices Laws. Simple as that. You could also write it in terms of root 3 squared. Because if you multiply anything by itself, it's just a square. And the square root and the square cancel each other. And that is equal to 3. And we can show that because we know that 3 to the power of a half multiplied by 2 is also just 3. Because half times 2 is just 1. Again, go back to this. So that's 3 different ways you can prove that if you multiply side by itself, you just get the number. So as a general case, root a times root a is just a. And this applies, ooh, that's more like a 9. And that applies for everything, no exceptions. That is a general case for every single situation. So well, we can go on further. Let's look at division now. And when you divide surds, it's basically a very similar procedure to multiplying. You just take the numbers and you just divide them. So in this situation, put it all in 1. 4 divided by 2. And that will leave us, 4 divided by 2 is just 2. And that'll leave us with root 2. Simple as that. With the second situation, we got root 18 divided by root 2. So we put it all in 1. So we got 18 divided by 2. And that is equal to root 9. And we know root 9 is equal to 3. So we can just simplify it out to be that. And that's basically it for that kind of thing. So that's the 2 rules. Multiplication rules and division rules. Those are 2 kind of starting points. We will not be covering the addition and subtraction stuff because that kind of goes a bit more into crazy detail later on. So we'll be doing that when we look at the tier 2 videos coming up later on. So for now, these are kind of the standards that you should kind of get to grips with. So one final thing we're going to talk about real quick is when you have situations like this, root 18, root 20, root 45. And you can simplify these out a bit further. And to do that, you have to know the factors of, these numbers. So what I mean by this is, if we want to simplify root 18, we can say that root 18 is equal to 9 times 2. Alright? So we can split this up into 2 factors, where 1 is a square root, it will actually give you a proper number. So this is an example of that. So in this case, we have root 9 times 2. And we can split it up further. We know root 9 times root 2. And in the end, you're left with, this will give you 3, and that is just root 2 on its own. So you're left with 3 root 2. Now again, like a standard algebra, we don't put the multiplication between the 3 and the roots as well, because we just want to make it look as elegant as possible, make it look very neat. So we just omit the multiplication at this point. And so what we do, we have root 9 times root 2, and we just left it 3 root 2. Simple as that. So for the next situation, we can do the same. So 20, we can split this up into 4 times 5. And 4 times 5 is 20. But we also have the root 4 here, and root 4 is 2, and root 5 stays the same. So in the end, we have 2 root 5. And that's it with that. And now for the final situation, we have root 45. 45 can be written as 9 times 5. So we know root 9 is 3 from up here. So we just have 3 root 5. And that's another thing of simplifying sets. So we can get them into a simpler form, where we have it in the form of, a number, root, whatever. So it's to make it simpler and break it down to its, break it down to the simplest parts, basically. And this will help, especially for the tier 2 videos where we'll be taking a look into this again, where we have addition and subtraction, and we have to rationalize surds and all of that, but we're not going to do that for this video. So this is something you could probably practice. Remember that when you have, now this doesn't work with all surds, I should add. Obviously this won't work with all surds, because it definitely doesn't work for 5 or 2 or 3, for example. But whenever you have products where one of them will give you a number, a whole number, then that's when you do this procedure. But otherwise you can just leave it be. So for example, root 21, you can't really split that up, so you just leave it be. So that's all I had to say on Introduction to Surds. That is basically a standard introduction to it all, and again, we'll be taking a further look into this in the future when we look at, when we look further into rationalizing and, all that kind of thing. So thank you guys so much for watching, and I'll see you guys in the next video.